And I'm Hazel Garverick.
And she has a bachelor's degree in calculus.
And this is Late Night Math Talk. Tonight's first topic, complements and supplements of an angle. So we're going to start with complementary angles. So complementary angles are two angles whose sum equals 90 degrees. So let's take this 90-degree angle and say we draw an angle separating the 90-degree angle. These two angles, their sum is 90 degrees, so they are complementary angles. So let's say this angle right here is 40 degrees. And this angle over here is x. How do we solve and find 40's complement, which is x? What you do is you start out with the whole sum, which is 90. So 90 minus your angle that's given, 40, equals x. So you'd solve 90 minus 40 equals 50. So you know that x equals 50. You can check your math by adding the two angles together and making sure their sum equals 90. It looks like that checks out. That's a complementary angle. So we're going to move right along to supplementary angles. So supplementary angles are two adjacent angles whose sum equals 180 degrees. So as you can see here, angle A and angle B are two adjacent angles. Their sum equals 180. Okay, so let's say angle A is 80 degrees. And we know these two angles are supplementary, but we're going to call B, since we don't know the value of B, we're going to call it x. So next part is, how would you find this supplementary angle to 80? How would you find the value of this supplementary angle, which is x? So you know that it equals 180 altogether, so you're going to start with 180 minus the given angle, which is 80. So 180 minus 80 equals x. And you'd solve. So 180 minus 80 is 100, so you know that angle x equals 100. And you can check your math by saying 100 plus 80 equals 180. Looks like that checks out because they both equal 180, so those are two supplementary angles. So that checks out, and those are supplementary angles. And you can always remember the difference between supplementary and complementary because okay. You can always remember the difference between supplementary and complementary because think about this. Complementary and supplementary. C comes before S in the alphabet. So does 90 comes before 180 in the order of numbers. So complementary and 90, they come first, so they're together. And second comes the S, so supplementary, and 180 comes after. So that's how you can, it's a little brain trick to remember those two.
Also, C in complementary, so it goes CO. You can remember that it goes into a 9, to remember it's 90 degrees for complementary. And then for supplementary, that's 180 degrees, you can go and make this into an 8. And you know that becomes 180 degrees. Just another way you can remember the difference between complementary and supplementary angles. Okay, so we are back, and our next topic is finding measures of coterminal angles.
Okay, so to start out with coterminal angles, you're going to need to know two terms, which is the terminal side of an angle as well as the initial side. So let's draw our angle right here. And this is our angle. Okay, so everyone sees our angle. So this up here is the terminal side.
I'll just label it T.
And this down here,
this line,
the black line from 90 on, is the initial side. So coterminal angles are angles that share the same terminal and initial side as our angle written, but they're not the same exact measure. So a coterminal angle, one that shares the same terminal side and initial side, would be an angle that is this large. Because if you see like that huge circle I drew, that's representing our whole angle.
Going around all quadrants of the graph.
Yes, it touches all quadrants of the graph. So
this is, up here is 90, 180, down here is 270, and over here is 360, just to give you an idea.
Okay, so a coterminal angle, let's say this angle is 60 degrees, this little one, our little angle is 60 degrees. Okay, so all together, our angle plus its coterminal angle, it equals 360. So to find our coterminal angle, we do 360 minus our angle given, which is 60,
gives you
300. So we know that our coterminal angle is 300. You can check your math by doing 300 plus 60 equals 360.
The 300 is representing from your terminal side all the way around to your end of initial side, and this entire angle is 300 degrees.
So just to make sure you know, coterminal angles, they share the same initial side and terminal side. So this angle, there's its terminal side, there's its initial side, this 60-degree angle. See, now to find the coterminal, we want one that shares the same terminal and initial side, but it's not the same angle, so we don't want it to be 60. So it can go around more than once. The one we're using today only goes around once, but it has the same terminal side and it has the same initial side, this big angle. And it'd be 360 minus 60 equals 300. So that right there is coterminal angles.
Okay, so
We're back
on to our next topic.
Quadrants of an angle. So the quadrant of an angle, you'd start out with a full graph, which means you have your x-axis right here.
And your y-axis right here. So,
X-axis,
X,
y.
Y.
Okay, so boom, we got it. That's your full graph right there. So quadrant of an angle. There's no exact way to remember it besides the way of just remembering it. So you start here and you're going to go counterclockwise. There's 4 quadrants. This is quadrant 1. You'd go counterclockwise to quadrant 2. Keep going to quadrant 3. Wow. And keep going to quadrant 4. All right. So there you have it. Quadrant 1, 2, 3, and 4. So quadrant 1 is going to be in between 0 to 90. 0 to 90 degrees is quadrant 1.
Then quadrant 2 is from any angle from 90 degrees to 180 degrees. Quadrant 3 is any angle from 180 degrees down to 270 degrees.
And quadrant 4 is any angle from 270 to 360. So to find the quadrant of an angle, let's start with an example angle. So let's say our angle is 170 degrees.
So I'm just going to draw it in.
There's our angle.
So let's just assume this is 170 degrees.
Put a little thing right here so you can see. So that's our angle. It's 170 degrees. Yes, okay. So this big obtuse angle, 170 degrees. Now, how do we find what quadrant it's in? Well, you can do it by simply looking at it, or you can look at, if it's in between 90 and 180, it's in quadrant 2. So by looking at it, also you can find it's in quadrant 2.
So our angle of 170 degrees lies in quadrant 2.
Let's do one more. Let's say we have an angle of 30 degrees. All right, there's our 30-degree angle right there. Okay. So you can do it again just by looking at it. Looking at it, you can see it's in quadrant 1. Or you can think of the
0
parameters for quadrant 1, which is that it has to be in between 0 and 90
degrees.
All
so
right.
we know that this 30-degree angle lies in quadrant 1.
And that's how you find the quadrant of an angle.
Okay, and we are back and better than ever
With finding trigonomic functions of an angle.
All right, let's just go ahead and get right into it.
Okay, so how you'd start is you'd get 1 point on a graph. Let's say our point is 8, 15. So we're going to count over 8 on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8. And go up 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's
we
8,
know
15.
this is 8, 15.
All right, so we're going to draw an angle through that. And we're going to label this little angle down here O. Okay, so we want to find the trigonomic functions of that angle. And the trigonomic functions
We're also
are...
going to draw a line down, and we're going to make this easy and make it a right angle.
Right, because to find the trigonomic functions, we want to make it as easy as possible. We're going to make that a right angle. So, trigonomic functions, sine, cosine, tangent, secant, cosecant, and cotangent. So we're going to find all of those for angle O.
So, basically to start off, you need to find the sides of the right triangle. We went over 8, so we know this side length is 8. We went up 15, we know this is 15. We have to find C. The way you do this is using the Pythagorean theorem of a squared plus b squared equals c squared.
That Pythagorean theorem only works in right triangles. That's why we created the right triangle, so we could find this missing side. So 8 squared plus 15 squared equals c squared. 8 squared plus 15 squared is 64 plus 225 equals 289 squared.
280.
No, square root of 289. So the square root of 289 actually comes out really nicely. It happens to be 17. So our hypotenuse over here is 17. All right.
So now we have found all 3 sides of our right triangle, and now we can go ahead and actually figure out the trigonomic functions of our angle.
So we're going to erase this right here, just so we have some room. All right, so we're going to start with sin of O. So sin is opposite over hypotenuse.
From this
O.
angle. It's always going to be the angle closest to your starting. So sine is opposite, like Hazel said, 15
over our hypotenuse, which is
17.
So
now you're done with sine.
We found our sine. Now it's time for cosine.
Cosine is adjacent to this angle, adjacent 8.
Over hypotenuse as well, which is 17. So adjacent just means the one that's right next to the angle. So 8 over 17.
Now you're done with cosine. Now,
cotangent. No, tangent.
It's like a...
Okay.
Tangent is
Opposite
over adjacent.
So it's going to be 15 over 8. So those are the first 3 basic ones. Now you go to secant, cosecant, and cotangent, which I'll explain. Sin is opposite over hypotenuse. Secant is just sin flipped. So secant would be hypotenuse
17
over 15, which would be opposite. Okay.
Which also is, as you can see, is just the reciprocal of sine.
Yeah. So, and same for cosecant, it's just going to be the reciprocal of
cos. So we have hypotenuse over adjacent. Again, it's the reciprocal of cosine.
So cosine is adjacent over hypotenuse, cosecant is hypotenuse over adjacent. Now it's time for cotangent. Same thing, it's just the reciprocal of tangent. So it's going to be adjacent. Nope. Yep.
My bad.
Nope. It's going to be adjacent, which is 8, over opposite. Remember how tangent was opposite over adjacent? Cotangent is just exactly the opposite. It's reciprocal, and it's just adjacent over opposite. Okay, so
lastly, another way to remember these functions is a cool thing called SO, TOA. And this represents sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and lastly, tangent, opposite over adjacent. This can just help you remember
the first three. But remember the second three, which are secant, cosecant, and cotangent, they're just the reciprocal of sine, cosine, and cotangent. And that's all we have for finding the trig functions of finding the trigonomic functions of an angle. Oh yeah, okay.
Okay, so let's keep us going. We are on to finding reciprocal angles.
Reciprocal identities, not reciprocal angles.
Sorry.
It's okay. Jesus. So we're going from our last one. So remember in our last little segment, we taught you that we're using the same triangle. Sin of theta is still 15 over 17. Cos of theta is 8 over 17. Tan of theta is 15 over 8. Cosecant of theta is 17 over 15. Secant of theta is 17 over 8. And cotangent of theta is 8 over 15. So, reciprocal identities. We're going to write out the formula for you guys. So, to find reciprocal identities, you'd say sin of theta equals 1 over the cosecant of theta. Okay. And then for cos, it's 1 over secant of theta. And for tangent, it's 1 over the cotangent of theta.
So if you notice, it's just the reciprocals of what we found here, but basically it's 1 over the reciprocal of these.
Yeah, so the reciprocals are like the cotangent
so this will be
of
the
tangent.
Of theta, because it's the opposite. It's the reciprocal, and it's 1 over. This will be the cosine, 1 over the cosine of theta, and this will be 1 over the tangent
of theta. So do you remember how cosecant, secant, and cotangent are just the reciprocals of sin, cosine, and tan? Well, now it's basically, what this is basically saying is since cosine is already the reciprocal of sine, it'd be 1 over the reciprocal of its reciprocal.
Yep.
So it's the reciprocal of its reciprocal. It's not making any sense. I'm sorry, it's hard to explain. But just remember the formula, which is
basically this
1 over its reciprocal, 1 over its reciprocal, 1 over, it's just 1 over its reciprocal in simple terms.
That's the way you're going to have to remember it. This is purely just memorization.
And so we're going to show you how to just do 1, and we're going to pick sine for this one. So the sine
of theta
is 1
over the cosecant. We found out that the cosecant is 17 over 15. So we have 17 over 15. Now, we multiply by its reciprocal. So that would be 1 times 15 over 17.
We do that to get the fraction out of the denominator.
And anytime you're getting a fraction out of the denominator, you multiply each side by its reciprocal.
Flip and multiply.
The sine
of
theta is 15 over 17.
And does that check out? 15 over 17 looks like that checks out.
So, that is 1 more.
Check mark. And you do that for the rest of them, and you always want to make sure you flip and multiply to get the fraction out of the denominator.
And the way to check it is, that's why having all of these up here is an easy checker, because as long as your reciprocal matches, you know you got it right.
Reciprocal identities, might I say.
All right, so
we back.
6 out of 10. This is our 6th one. We can do this.
Okay, so this segment is going to be called Finding a Trigonometric Functions Using a Calculator.
So,
and
we have a guest.
We have a special guest named Mr.
Mr.
Calculator. He's joining us today.
He will be coming in handy.
Okay, so to start it off, before we show you how to use the calculator, we're going to start off with the basic triangle we've been using, which is our 8, 15, 17. So for this, we're going to find the trig functions using a calculator. So we're going to find the trig functions. This is going to be angle A.
Let me just label it.
And we are going to find the trig functions of angle A. So it starts off with sin is opposite over hypotenuse. So we know it's A over 17. And the cos of A is going to be adjacent over hypotenuse, 15 over 17. And the tan is going to be opposite over adjacent, 8 over 15.
So these are just showing you the numbers that you're going to end up plugging into your calculator, but we just wanted to show you these so you could see a visual on how we got these numbers before we actually plugged it in.
So now what we do is we're going to start using the calculator for you guys. But the reason we're not just going to plug in like 8 divided by 17, because that doesn't get you the sin. It doesn't, so we'll show you how to plug it in on the calculator to get sin. You can't just divide. Okay. So we're going to start with sin of angle A.
So to find the angle, you have to use the opposite.
The inverse.
So the inverse of sine. So your sine is right here. But because you're finding the angle, you have to use the second degree one that says sine of -1. Sine of -1 will get you your angle of A. So for number 1, you hit second, gets you sine of -1, and then it's 8 over 17. So 8 divided by 17. So the sine of angle A is 28 degrees. So sine of angle A gets us 28 degrees approximately. Okay, on to the next one. Cosine, second degree again. So we have 15 over 17. Gets us 28 degrees approximately. Cosine of angle A gets us 28 degrees approximately. And lastly, we have the tangent, and we have 8 over 15, getting us 28 degrees.
So that's just extra confirmation that our angle A is 28 degrees. So then, what would our other angle be?
Now,
so just quickly, this doesn't go along with the trig functions, but this angle, we're gonna do it. We're gonna do it.
Okay. So now, sine of B would be, sine of angle B would be opposite.
We're just gonna do one for you
over
guys.
17. 15 over 17.
All right.
So now, plug it into your calculator. You go, remember to reciprocal, because you're finding the angle. Inverse. And you go 15 over 17. When I say over, I mean division. Oops. 17. You get 61. So you get the sine of angle
61, but it's 61.9, so it's gonna round
to 62. So,
and to check if we got it right,
you can
you know that this is 90.
Oops, my bad. 28 degrees. 2 plus 8, 0, 90.
And that's perfect, because these two angles have to equal 90, because with this 90, it equals 180, and that is the sum of all three angles of a triangle. So it checks out. Woo!
So this one is solving a right triangle given one angle and one side.
So we have drawn out for you the right triangle, and we've given one angle on one side. So our side is 10 degrees and our angle is 28. So our two unknown sides are going to be A and C, and our unknown angle is going to be X. So to find C, we could do sin of 28 equals 10 over C.
So sin of 28 degrees equals opposite 10 over
hypotenuse
of
C.
C. To find this, you go times C by both sides. So you get the sine of 28 times C equals 10. You want to get C alone, you divide both sides by the sine of 28. So to get your actual formula, it'd be C equals 10 divided by the sine of 28. And that's what you're going to be plugging into your calculator.
Okay. I'm going to plug it in the calculator. You guys already know how to do this because we taught you in the last one. So it's going to be 10 divided by the sine of 28. Okay. And that gets you 21.
So that means this is 21.
So our hypotenuse, C, is 21. So we're going to erase C. And now we know that our hypotenuse length is 21. So now all we need to find is A and X. Well, X we can find because the whole sum of a triangle, all three angles must add up to 180 degrees. We know that since it's the right triangle, there's already 90 degrees. So 180 minus 90 is 90. So you know that these two angles have to add up to 90. So we do 90 minus our given angle.
90.
So 90 minus 28. Okay, that equals 62. So we know that X over here is 62. All right, now we only have to find A. So we could do that in many different ways. We could do.
You can use it finding this angle.
You can
or
say.
this angle.
You can say sin equals A over 21. Let's do that. Sin of 62. Oh Jesus. Okay. Sin of 62 equals opposite A over hypotenuse 21.
So this one's easier, not as much actual work. Multiply both sides by 21 and you will get your answer.
So 21 times the sin of 62. So sin of 62 is about 0.8829. So we're going to times that by 21 equals. It's about 16. It's 18.5. So we're going to round that to, actually we'll leave it at 18.5. Why not? So A equals 18.5. So just by given one angle on one side, we have solved all the values.
We have found C, we have found A, and we have found angle X.
So we just solved a right triangle in the given two angles. And this segment is solving a right triangle if given two sides. So we've written out our right triangle right here, and we've given you some sides, the sides that we've been previously working with, which are the side of 15 and the side of 8. So let's start by just finding the hypotenuse, which we know we're going to use the Pythagorean theorem. So it's a squared, which is 8 squared, plus b squared, 15 squared, equals c squared. I mean, we've done that multiple times. Well, we just know, we've done this so many times for you guys, we know that c equals 17.
C equals 17.
Alright, so instead of x, we know 17. So we've already found one side. So now we just need to find these angles. So, and we just taught you that in the last one too.
So, we will now go
sin of A.
Sine
of A. So the sine of A is going to be opposite 8 over hypotenuse 17.
And then you plug that into your calculator, and
we're going to do the inverse. Do you remember what we did last time? So we do second sin. Okay. Second sine, which is the sine -1.
And that's what you use, the sine of -1 or the inverse when you're trying to find the angle. You use the regular when you're trying to find the side length.
And then we do 8 divided by 17. Enter. So this angle A, is going to be about 28 degrees. Remember, this is what we did last time for you guys.
We're using the same numbers so you guys can.
So let's just make it easy, and like we already know that we can find this without having to do the sine of B. And so remember, 180 minus 90, so it's 90. So you know that these two angles, their sum is 90. So it's going to be 90 minus your given angle, which is 28 degrees, which equals 62 degrees. So B is 62 degrees.
Now, you have found your right triangle sides.
All your sides and all your angles. This segment is called Find the Length of an Angle when elevation is known. So, we drew out a little fun picture for you guys. This is Anna.
This is star guest Anna.
And
we're trying to figure out how far above her head the flagpole is.
so basically why we do it from her head, it's basically her eyesight, so we want to make sure the angle is as accurate as possible, which means it's coming from where her eyes are looking. Okay, so her eyes are at about 5.3 feet, because that's how tall she is, that's how far her eyes are above the ground. So we know that this is 5.3 feet. Okay, so
They give us
the angle
is 26.
that this angle is 26. So to find A, you have 123. You know that Anna is 123 feet away from this flagpole. Flag. It's a good flag. Okay, so to find A, what trigonometric function would you use?
What's opposite
over adjacent. Tangent. So the tangent of 26 equals A over 123. Now we have gone over this with you probably 5 times now. You just times by 123, get that out of the denominator, times by 123.
So, A equals tangent of 26 times 123. So A equals,
It's about 60.
60.
So A equals 60. So this right here, A, we know that
This
is 60.
feet.
But that's not counting this right here. So they want to know the full length of the flagpole. We have 5.3 plus 60. So you just do 60 plus 5.3 equals 65.3 feet. So now we know that this flagpole is 65.3 feet. And that's how you do that problem. All right,
so
this is our last and final segment of
the night.
Okay. All right, so we coming at you live with find the angle of elevation when the lengths are known. So I'll just explain this for you really quick. We got this nice old dandy building over here, drawn courtesy to Maddie Ravera with a PhD in mathematics. And the building, we have the two known lengths. So the building is 30 feet tall. That's a
Just know that's not to
it's
scale.
a short building. And then the lengths from this angle of elevation, it's called angle of elevation because it's going up. Get it? Because we're looking to the top of
See,
the angle.
here's the sun.
There's the sun. Okay. We're looking to the top of the building, so it's the angle of elevation because we're looking up, not down. Okay. Anyways, the length from the building to where the angle is 40 feet. So what would work for opposite over adjacent?
Tangent.
So the tangent over here. The tangent of angle B equals 30 opposite over 40
Adjacent.
adjacent. So remember how we do that? We just do the inverse. We've taught you this multiple times now.
Also, remember, inverse is because we're finding the angle. If we were finding a side length, it'd be normal.
Okay, so we're going to do second tan, so it's little tan -1, and then we're going to do 30 divided by 40. It's simply just a fraction, but we type it in the calculator as 30 divided by 40. So tan negative, so inverse of tan times 30 divided by 40 equals 36.8. So it's going to be 37. So this angle measure, B, is 37 degrees.
So, you have found your angle of elevation. So the angle of elevation is
37
degrees.
So that's all you need for that one.
So, that is another thing
We have
well
crossed off the list. Okay, wait, no. Check mark.
Hey!
Yo, guys, that's gonna wrap it up for tonight. So thank you for sticking with us, viewers, for the late night math talk with Hayes and
Mad.
So we hope that you've learned our 10 concepts, We've informed others. 20 points. We've had plenty of creativity with our joking,
10 points.
10 points. And we've got great communication going back and forth.
Scratching and killing it. Just really
just
put
killing
ourselves
it.
out there.
From, the PhD in mathematics to the bachelor's in calc, we just killed it with communication, 20 points. So,
We are so thankful.
and, our content, 10 topics, 50 points. We did that great as well. So we just, we just want to say thank you, viewers. We love you guys.
We thank you
in the
so
crowd.
much for sticking with us all night.
We love you too.